meets mind, we ponder, we dream.
Sounds great. So thank you so much for coming on the show. It's great to finally meet you because this is how we meet each other nowadays, through Zoom, right? Although I wish I were in Costa Rica with you.
Exactly. It would have been fun.
Yeah. Why don't you tell us a little bit about yourself and your organization and what you're passionate about?
All right, let's start with what I'm passionate about first of all.
That's the most
I'm
important thing anyway.
Yeah, I'm passionate about um, professionally network and network security. That's always been my life right from the beginning. I just love that networking does what it does. It's changed the world. And I want to get more people involved in that, and I also want to make sure that they can do it privately. And privately includes obviously security, right? You can't be private unless you're secure. So that's why we started the company, to allow people, entities, and things to talk across hostile networks privately. And we started that journey 5 years back, and it's been a bold idea because 5 years ago, people were saying to us, "Privacy's dead," right? I haven't got any privacy.
Yeah.
I think more
Didn't
recently,
Scott McNeely came out with that famous statement, right? Like way
yeah,
back. It was Sun
yeah,
Microsystems.
absolutely,
Said privacy
yeah,
is already done. Like, get
it's
over it,
done.
right?
Get over it. Yeah. Fast forward to now, I don't think it'd be any more important, right? So you need to build trust in the network, and the only way you can do that is make sure you can communicate privately.
Right.
But yeah, sometimes you want to be anonymous. Sometimes you want to prove to somebody that you're over 18 or over 21, and you don't want to give away any other information because you'll get tracked, and that's when you turn into the product.
Right.
So
Well, that's
yeah.
crazy. So how do you do that? I mean, actually, so what's your name again? Your company?
Yeah. So
You
my
forgot
name's
that
Colin.
part.
Yeah, no, my name's Colin Constable. I'm one of the co-founders of a company called AtSign. And we started this journey, as I say, 5 years ago. And yeah, I'm so passionate, I forgot to mention my name, clearly.
By the way, I love the name of your company. I'm like, how do you say, like, somebody, my email is Colin at @sign. Like, what do you mean,
Exactly.
you mean two at signs? Like one at
Yeah,
sign to the other?
we were told right at the beginning that you have to stand out with a startup name, and nothing could be better than standing out by not being able to explain how to send email to you. Yeah, and we got
Exactly.
very lucky on the domain name. It was quite funny. We were trying to look for a domain name, and we came across we knew had to have an at sign in it, and so a signage company had gone out of business in Texas the week before, and at sign was up for auction.
Oh,
So that's how we
fantastic.
like it's what we call it.
Serendipity.
It's what we call at magic of the company. It happens consistently. Just as we need something, something appears.
I know. It's like serendipity.
Yeah,
I love that.
just
It's the
unbelievable.
law of attraction, right?
Exactly.
Like thinking to yourselves, this is what we need, and then boom, it just pops up.
It just pops up. Yeah. So we're always looking for at magic. It
I love
happens
it.
to
I
us.
love it. So
Yeah.
this
Yeah.
this is the thing. You're interesting. It's an interesting space because, I mean, all of this, all of these systems, especially AI
Yep.
nowadays, they
Oh,
need data.
100%.
They
Yep.
need data, but at the same time, you want to balance it with privacy. And then I've seen what
Yep.
happened with Apple and Apple Intelligence, and they have this whole framework to try and
Yep.
keep the data private at the same time as it's being used for AI. I mean, how do you reconcile those two things? It sounds like an impossible task.
It does sound impossible, but it is possible. And the way to do that is make sure you know who owns the data.
Mm,
And whoever owns the data can share their data or not share their data, depending on whether they trust whoever they're going to share the data with
right.
is using it effectively or usefully, or paying money for it, whatever the use case is. But having the owner of the data ownership very clear, and being able to cease sending data to people that you don't trust in the future is very important, and being able to pull that data back is possible, but it's only possible if you write a new internet protocol, and that's what we started doing 5 years ago.
Right.
either either a very bold or a very stupid move was to actually write. As it turns
Do you
out,
remember?
writing
I don't
new,
know. Do you remember
new internet
Internet
protocol is
2?
difficult.
That didn't do
Yes, I
too well.
remember that. Yeah, no, yeah. So we're definitely internet optimists, and we love certain things on the internet the way it's done. So we're huge fans of TCP/IP. We're huge fans of TLS. So guess what? We use that. We love the way DNS is architected. So we took all the best bits and we threw away all the bad bits. And yeah, like everybody else on the internet, we stand on the shoulders of giants. So
Nice.
we just added our own tweaks to allow people and entities and things to share information in a cryptographically safe manner, I guess.
Hmm.
Yeah.
So how does that instantiate itself, right? So right now,
Yeah.
I go onto Facebook and
Yep.
as soon as I log in or sign into Facebook, they give me this giant terms of service which says basically we can do whatever the hell we want with your
Whatever we
data.
like. Yeah, exactly.
You can't do anything. So I mean,
Yeah,
how does yours work as opposed to what Facebook
you
is
got
doing?
it. So, number one, we don't use native web protocols. Web protocols have got an awful lot of history. And if you're using web, then you have to have a web server. And if you have a web server, there's an administrator, and the administrators can see all your content. So, yeah, in the case of Facebook, yeah, if you put something on Facebook, Facebook can see your content. That's the whole premise
Oh
of the
yeah.
business model, right?
Yeah.
But what if that wasn't the case? What if I could share data from me to you, and I'd only share it with you, and I could give it, I know, a time to live, and it would just evaporate. That's how our protocol works. So instead of looking up, going on a web browser and going to a website, you have what we call an @sign, which looks like just a social media handle, but it's a handle that you own, and you own all the data behind it. So my @sign's @Colin. And I can share, data with you if I knew what your @sign was.
Oh,
That's the
do I
basic
sign up?
premise.
So how
Yeah,
do I
how
sign
do I
up?
get an @sign? Yeah,
Yeah,
how do you get an @sign?
yeah. So I
Yeah, you
just
go
sign
to
up.
you
Go ahead.
go to @sign.com, and you can get an @sign for free. And the catch there is, why is it free? Well, it's because you don't choose what the @sign is. We have an algorithm that will give
What,
interesting.
I can't use my brand?
You can't. Well, you can, but you can pay for that. So that's how we monetize.
Ah, okay, gotcha.
Yeah. So I did pay. I did pay for @Colin, and yeah, it was expensive for sure, but yeah, I think worth it. But you can get that time for free, but it'll probably be, I know, Crunchy Frog or Wise Owl or something completely random. But what we found interesting enough is some people get very, very attached to their random @sign.
Oh yeah, I
And,
love those.
and
Sometimes
then
they're
it's
just
fine.
great.
Some of the, yeah, so I think we maybe did too well with the algorithm. People give, but if you do want to have your brand, or you want to have your first name or last name, then you can have that. It does cost a little bit more money, that's all. But once you have your @sign, then you can communicate with other people with @signs, or other entities. Companies can have @signs, or really interesting AIs can have @signs. So AIs can talk to you, and they can talk to each other securely and privately, and things. So you can talk to any sort of internet connected device.
Okay, so walk me through this for a second. So I have an @sign, you have an
Yep.
@sign. I
Yep.
want to share some private information with you. How would
You
I
got
do
it.
that?
Yeah, so you have an application. So pick whatever application you have. We have some applications that are on the in the Play stores and Microsoft Store and all the rest of it. So one of my favorite ones is just a really simple use case of sharing files. It's called Atmosphere Pro. And all you need to know is what my @sign is, and you can share a file with me. And this was actually developed for an NGO at the beginning of the Ukraine war, so that their folks could share data with other people in Poland, as it was, to rescue kids.
Right.
And the obvious question is, why the hell didn't they use Signal or Telegram or all these other things?
Yeah.
And the answer is they are or were keyed against phone numbers. And if you're in a hostile environment, you don't really want to be keyed to a phone number. So
exactly.
Probably not a great thing to be keyed to that. And the other thing we learned, which was really interesting, was the application wanted it to be in plain sight, so hidden in plain sight. So it's just on. You can download it from the App Store right now and play with it, get an AtSign and all the rest of it. But that meant that if somebody they met in the field and they trusted, they could log on, get a free AtSign, and then they could send data back to Poland. So being able to onboard really quickly and just expose what your AtSign is, and in their case they were just using random free ones, and then they can send data back and completely anonymously, right? So
it's privacy, so it's encrypted, so it's sitting on my phone. I send
sitting
it
on
to
your
you.
phone.
It's encrypted through in transit, and it's encrypted when it gets there. And
exactly.
and you're able to look at it.
Yeah, so the way it sort of technically works is the application would derive a new key, AES key in this case. It will then encrypt the photograph, video, whatever you want to send with that key, and it will upload it to a random place on the internet. It's encrypted, and that random place on the internet basically keeps files around there for 6 days.
Wait, tell me about these random places around the internet. Do you run those random places around the internet, or?
So we do. We run a few of them, but also the software is open source. It's called FileBin, and you could use the filebin.net, I think is the website. It's open source. We work with the team to get that software into a Kubernetes cluster, so it's highly scalable and the rest of it, and that's all we use. So encrypted file goes up there on a random URL, and then you notify whoever you want to send the file to of the key and the location. So now you have the key and now you have the location, so you can go to the location, pick up the file, it's encrypted. You always have the key, so you can decrypt it, and magically it's wherever you logged in with your AtSign, you can get that file.
Oh, fantastic. And does the interface work also? So like that's great for techies, but somebody who knows nothing about sending files to each other, I'm assuming that you can use the same interface to just go send, and it's done.
I mean, the interface is beautifully designed, so it just looks like a regular application. It's just a regular UI application, like on Android and iOS and Windows and Mac.
So you're providing the infrastructure for these apps to use this. Platform.
Yeah, exactly right.
So you don't do you have any chat solutions like a Telegram clone or a Signal clone?
We don't currently, but if anybody wants to develop that, and I welcome it, that would be awesome. We really did Amazon Pro really for this NGO, just to prove what we could do with the platform. Right. You can do countless things. So everything we write, we use our own SDK. Everything we've done is open source. So if somebody has an idea and they want to do it in a private and safe manner, they can use our SDK to write their own solution and go to market with it. That will
fantastic.
Be awesome.
So you're looking for developers right now to write these solutions. So you've seeded the market with a few solutions already, so that
you got
it's a proof of concept.
Exactly. So you can.
And then you're looking for other developers. Okay.
Exactly. Developers, companies, people that want to embed privacy into their hardware. So we have SDKs in various different languages. The most recent one, which is just coming out of beta right now, is C. So you think like, why are you going back to C, right? And it's because C is very compact, and older equipment, the only way you can get software onto them is C. So if you're running microcontrollers and you want to do data transfer to and from a microcontroller, we have the C SDK, and you can use that.
Oh yeah, well, there's nothing wrong with C. I think some of these older languages are actually better than some of the newer ones, because they were made to run closer to the iron anyway. I mean,
very, very close to the iron. Doesn't get much closer. Yeah. So
exactly.
C's probably as low as we go, but we have other SDKs in other languages. We started with a language called Dart, and that turned out to be a very good choice, because it runs on anything without having to change any of the underlying code.
Oh, nice.
And Flutter, which you may have heard of, is built in Dart, so it's a framework on top of Dart. So again, we got sort of lucky with that. We started with Dart, then we wanted to have UI apps like for the NGO, and Flutter was just a natural progression. So nice. I mean, sometimes you have to have that app luck, right? That app magic luck.
Just so tell me about. So you're one of the founders, right? Or you're the founder?
Yes.
Or okay?
Oh no, I'm one of the founders.
One of the founders. So like, what drove you to come up with this? Like, what was the impetus
It,
for coming
it
up
was
with
an
this
argument. All the best startups start with an argument.
So all the founders were in the same room, like
It was actually two of
playing
us.
poker or
Yeah.
something like that. And you're like,
Yeah,
God damn
was
it!
two.
I wish this existed.
Yeah, it was basically two of us, myself and Kevin. We were, I think actually at a I'm trying to remember exactly where we were. We were at Plug and Play Tech Center, which is a incubator in Silicon Valley.
Oh yeah, I know
And
them. I know them very well.
yeah, the team there are awesome. And anyway, we were just having a cup of coffee, arguing about one of us, I can't remember who, somebody had logged into a website and like, damn it, like, why have I ever given all my information away just to log into a website? And then, like, well, that's because the whole thing's ran the wrong way. It's like, well, you got to log into every service. That's ridiculous. You got to log into the internet. That's ridiculous. Why doesn't the internet log into you? And like, that's a really good idea. This was over a decade ago. And we dug in pretty hard, and one of us, and I'm pretty sure it was Kevin, but one of us said, what's the simplest way to assert an identity on the internet? And we'd both been an identity a long time. Me in corporate, him in startup world, and identities is like a golf swing. It's impossible, right? It's literally impossible. You can't do identity on the internet. But turning that on its head and say, what's the simplest way to assert an identity? More coffee was had, more argument was had, but it's basically a unique string. You can assert an identity on the internet with a unique string. We've already seen that with DNS, right? So DNS asserts a DNS string, and it turns into an IP address.
Exactly.
Our idea was essentially, well, what if you could have a similar string, but it could hold all your data?
Oh, I love it. Data. I love it.
And that's so we started writing code, and we got DNS, and we got blockchain, because back in 2014 that was super hot.
Oh, you had to use blockchain.
I mean, they had to use blockchain, right?
Just like you have to use AI right now. Like there's no way around it.
You've got no choice. You've got no choice. So we mashed them together, and we both looked at each other and like, this is not going to scale. We both worked in telcos, and it's just not going to scale. So we put it to bed. There was two things that were holding us up. And we literally waited 5 years, went off our own way, and then over another cup of coffee, had another argument, said, well, let's just drop everything and see whether that idea we had 5 years ago is actually valid now. And it turned out it was. So that's
that's the thing. It was right that you had to wait for the right moment to bring it back up.
It's always about timing.
Yeah,
it's always timing.
Timing is it.
100% timing. Yeah. So with the two things, just for your listeners, one of them was, if you're going to have a secure system, you have to cut cryptographic keys at the edge. And, over a decade ago, you'd be waiting 20 minutes for something to cut a set of RSA keys or something or other. These days, a SIM card can do it in less than a second. I mean, that's how fast you can cut cryptographic keys.
Yeah, the technology had to catch up with your idea, basically.
A crazy idea. Yeah, absolutely. And the other thing was DNS is very difficult to manage, and I mean, I love it to death, but if you've got to make a change, you could wait days for that change to propagate across the whole internet, and so you can't use that as a database. So we needed in-memory databases that were horizontally and vertically scalable, and at the time Redis wasn't a thing, and now it's a thing. So we use Redis these days. You can pick whatever favorite database you want to use. So all we needed then was a new internet protocol to join keys at the edge and a directory service in the middle. That's all we needed.
No biggie.
No, not
just
easy.
a brand new internet protocol.
Yeah, exactly.
So where's the data being actually stored? So I have data on my phone, right?
Yeah, you got data on your phone.
And the data is the data actually being replicated and stored in these databases that you're talking about?
No, so the database was really only for a directory. So, and what the directory does is gets your @sign, just like DNS. You look up your @sign, and you look up in this directory, an @sign, and it will give you back just two things: the DNS address and the port number that a Docker container containing your data lives. And this is a Docker container that lives on the internet somewhere. You can run it yourself. We can run them. Doesn't really matter. Just it's a location on the internet where that is.
And how discrete is that? What's in the container? Anything you want?
Really good question. Yeah, pretty much anything you like, as long as it can be turned into a string. And the catch here is all that data, apart from public data, if it's public, it's not encrypted because it's public. Like your public keys are not going to be encrypted because you want to advertise those.
Right.
But if it's not public data, it's encrypted with a key that Docker container hasn't got. Doesn't get safer than that, right? So everything's there that you want to share, but it's encrypted with keys that infrastructure hasn't got. And you keep your keys on your device. So if you're running Amazon Pro, your cryptographic keys will be kept on your device. Right. And probably if you're using an Android or iOS device, it will be in the secure enclave on the chip.
Right.
For those keys. So there's like a chain of trust that's brought up. So the keys are always at the edge. And there's no sort of central key management because that just scares me to death. Because
you don't want
I know
that.
they're super secure. I know they're super secure, and lots of people trust them. But
right,
I worry. Right, if you want to break into the whole of the AT system, you'd have to break into everybody's cell phone. Good luck with that.
That's the best way to do it. You need it to be fully distributed, just like
that. Has to be distributed. And I mean, taking cues from the blockchain world, right? So everything's
so
at the edge.
So I can put anything I want in this. In this. But what if I want to, do I have to have multiple ones? Like, let's say I have a block, which is say payment information, right? So I have, here's my preferred credit card. Are all my credit cards in this one module, or are they all across, or how does that work? Like
they would be in that data store, but encrypted with different sets of keys for whoever you're interacting with. So if you're interacting with your bank, then it'll be one set of keys. Yeah.
So if I want to tell Amazon, hey, here's my payment information, I would send something to them, and then they would go retrieve it.
Yeah, exactly. You just say, this is my AtSign. Go pick it up at Amazon credit card, and they would download the encrypted just for them bit of data, and they would have the key, and they would open it up with their private key, and boom, they've got your credit card. Now, I'll give you another little nuance here. What's super cool is you could say, credit card at Colin, right? That's my credit card. If anybody wants to know my credit card, it's credit card at Colin. Now, depending on who you are, and you have to cryptographically prove who you are, I can give a different answer. So if Amazon looks it up, it's one credit card. If eBay looks it up, then it's a different card.
Oh, interesting. I like that.
So you can have the same location, but have, and we learned this from, we're a very people-oriented company, and you may have noticed this with people, is you ask people the same question, depending who's asking, you might get a different answer.
Oh, yeah. Absolutely. That's being a human being.
And there was no protocol on the planet that would allow us to do that.
Yeah. Because people sometimes people say it's like, who's asking, right?
Who's asking? Yeah, exactly. And this is the one protocol where you actually do know who's asking before you have to give an answer.
Right.
And if you don't know who's asking, you can give a public answer.
Yeah.
So I could say, I know, location at Colin. I could say Costa Rica, but for you, maybe I'd say you're in Costa Rica airport.
Yeah. So you're not looking at the sort of like the end user to manage this data. You're looking at the application provider, so the developer to manage to do all this management, right? Because I remember, I mean, I worked with the World Economic Forum probably maybe like over 20 years ago, and they were looking at the problem of the personal data store, right? Because
this is a personal data store. Yeah,
it's a personal data store. But what ended up happening is that we realized that sort of end users, they don't really care. Right, they want their data to be managed, but they don't want to manage their data, right?
Yeah,
so
exactly.
What you're looking at, so what you're providing is the framework, so that a developer can come in and manage the data for the end user, because they're gonna want. Well, I think on Amazon to have this card, and I want so and so to have this card, but I don't want to have to orchestrate all that. That's what your software does.
That's exactly what the software does. And what's really confusing to developers, and it does hurt your head as a developer. So if you want to go on this journey with us, just expect it's going to hurt your head a little bit, is imagine writing a application where you're providing all that orchestration around data, but you can't see the data.
Yeah.
You haven't got the keys. So I think most of us as developers were used to going into the database and seeing everybody's credit cards, and they can
we
trust
just
us.
you just trust us not to do anything with it.
No, not with AtSign. So you basically have to set up your own AtSign as a developer to see the data because you have your own keys. Now you can still do that orchestration, but you don't get to see my credit card.
Yeah. Which should be fine. I shouldn't need to see your credit card, right?
There's no reason, but we're used to it. So we think, I mean, this is some of the stuff we went through maybe 4.5 years ago. Is like, why is this really hurting my head, right?
It's a black box. Ignore it. The data's in there.
I can't do that as a developer, right? So yeah, but once you get used to it, it's so freeing. It's so freeing.
Yeah. No, I actually, and I love this concept. But so it's time to think like a futurist to see your 2030 for 10 years from now. Where do you think this is going to be? I mean, is this going to like take over Internet One as the infrastructure, or where do you see yourself going?
Yes and no. So I think it's the next version, and it builds on everything we've already got. So we'll still have IP. I mean, I don't want to get rid of IP. Everything we do is running on IP. Everything we do is running on TCP. Everything we do is running on TLS. So we better have all that infrastructure. But the infrastructure is getting far too complex for us to do really cool stuff. And there's not a universal namespace. And we have AIs that want to get data, and I want to feed some AI's data, and I don't want to feed some other AI's data. And I want people to be in charge of that control. Right. I don't want it installed on my washing machine and random stuff happening. Right. I should have a washing machine that says, "What's your AtSign?" and I should have a TV set-top TV box that doesn't take a PhD to set up. And you can do that by saying, "What's your AtSign?" And it can exchange data, and it will just automatically set up. So all these new experiences are driven by having addressability and accountability and context, and that's essentially what we provide. So what I hope to see in a decade is really, really cool experiences driven by this really simple underlying protocol, which is what the internet, we call it version 1.0 right now. It's changed the world, but it's way too technical to do these things that we wanted to do. So if I have an AI that's looking at my gate at my house, I want it to automatically open when it sees somebody's registration come by. And I know I can do that right now, right? I mean, it's really easy to do if you're a technologist. But I can't buy a widget from Home Depot and just put it on my fence and magic to, I can't imagine it to happen. What if I could? Well, I could, give the widget an @sign, give the gate an @sign, and it says, where's your @sign? And these are the list of people that are allowed in, and it just magically integrates, right? Because it's abstracted the whole network. Instead of talking IP addresses and all that technical mumbo jumbo underneath, it's just talking @sign to @sign. So if you can abstract a problem into this @sign speaks to this @sign speaks to this @sign and map that out, I guarantee you can write that software easier using our platform than trying to do all the loops and hoops we do today. And that just drives really, really cool experiences. So imagine you're in a hotel and you close the door, and as you go to the Starbucks password, they say, "Hey, Colin, here's your coffee."
Yeah.
There's no reason why that can't,
I want that now.
There's no reason why that cannot happen, right? If we're talking @sign to @sign rather than, trying to integrate into the Starbucks API to get a cup of coffee. I mean, how many developers?
It's doable today, right? But it's a huge pain.
It's so complicated. So I want those experiences that I think we all want, but it's just too difficult for technologists to do and keep up with the complexity. And networking hasn't had a global abstraction layer for 50 years, right? The first time we really had that was when Vint and the team started putting together TCP in 74.
Exactly.
So that was a global abstraction, global addressing scheme. And we need the same thing, but abstracted up one layer. And that's really what.
But these are addressing schemes for us as humans, as individuals.
People, entities, and things. People, entities, and things.
Exactly.
They're the 3 dimensions. And I'd love to be able to just interact with an AI and I don't care where it is. Don't care, right? Don't care. Why should I care?
Yeah, it doesn't matter to us, right? We just want to get
what we
get.
I just want the experience. And what we have at the moment is people with, our technology breaks down, so we have to insert people who have mind-numbingly boring jobs to be able to act as that glue. Like, nobody wants to do that.
No. So you're saving humanity at the same time.
And
they don't have to do the boring jobs anymore.
It's all about experience, right? And having a really cool experience. Yeah,
absolutely.
Absolutely. I think that's what it is.
This has been so cool. I love this concept. I'm going to sign up immediately if I can.
All right.
I wonder what it's going to give me. So if somebody
I don't know. Don't blame me. You can blame Ashish who wrote the algorithm.
So if someone wants to get in touch with you, what's the best way? Just go to atsign.com, or do you have a
link? Go to atsign.com. Yeah, I'm on LinkedIn. Colin Constable on LinkedIn. Drop me an email. That's fine as well. Colin@atsign.com. It's
fantastic.
AtSign.
Well, this has been great. So I will put all this links in the show notes. So if anyone wants to get in touch with you, they can go direct. So thank you so much.
That would be awesome.
Great. Enjoy the flight back from Costa Rica. I'm glad you enjoy.
It's gonna be good.
Have fun.
Thank you so much. Cheers. Bye.
Pixels and philosophies merge and mold, a future untold, unseen.